Today we're going to talk about absolute value equations and inequalities. In order to do that, we need to understand what absolute value means. So if we have absolute of x, that's equals to 2. This means that x right here can be either 2 or negative 2. Why is that? Because absolute means distance. So this is asking from 0 to what number your distance is 2. So if we have a number line, this is 0. This is going to be 1, 2, 3. This is negative 1, negative 2, negative 3. Your distance from 0 to 2 is 2. When from here to here, this is the 2. Or from here to here. So from 0 to 2, your distance is 2. 0 to negative 2, your distance is also 2. So you could say that your distance from 0 to 2 or 0 to negative 2 is 2. If you have absolute of x equals to 5, then we know that x have to be either 5 or negative 5, because the distance of 0 to 5 or 0 to negative 5 is 5, right? It means whenever you are taking absolute value out, you're going to put one with the positive, one with the negative signs. So whenever you're taking absolute value, put plus minus signs. So with that in mind, let's see if we can solve. So example 1, absolute of 2x plus 1 equals to 7. So long as you have only absolute one side, so on the left side, you only see absolute value, nothing else is attached to it. Then you should be able to take out that absolute value and put plus minus sign on the other side. So it'll be 2x plus 1 equal plus minus 7. And then you solve as the linear equations. So then you subtract 1 from the both side. You get, when 7 is positive, you get 6. When 7 is negative, you get negative 8. And then when you divide both sides of equation by 2, you get x equals 3. And negative 4. And we know that any of these problems solving equation, you should be able to check them. So if we wanted to check, to show you, replace back into where you started. This should be equals to 7. So it'll be 2 times 3 plus 1 is 7, right? 6 plus 1, 7. And if you replace with negative 4, that's going to be negative 8 plus 1 is also 7. So it checks out. Your solution is 3 and negative 4. If we're looking at the second one, before I take out absolute value, you need to isolate absolute first. So you're going to isolate absolute. It means you need to get rid of plus 5 before you take out the absolute signs. So then you're going to subtract both sides by negative 5. Then you get absolute of x plus 3 equals 7. Then you can take absolute sign and put plus minus sign on the other side. so that your x, now subtracting 3 from both sides, will be equals to, when 7 is positive, you get 4. When 7 is negative, you get negative 10. What about C? Here, I see more than one thing that I need to get rid of before I take out absolute sign. I see the addition here, and I see the multiplications. So we wanted to get rid of those. So I wanted to isolate absolute value first. So let's do subtracting 5 first. I get 3 times x minus 4 equal, that will be negative 1. And then when you divide both sides by 3, you get absolute of x plus 4 equal negative 1/3. From this point, I don't have to go any further. Why is that? Because absolute value cannot be never equals to negative numbers. You see this negative right here. Absolute value is distance. And distance cannot be equals to negative. So in this case, no matter what value you inputted here, it will be never equals to negative value. So in this one, you have no solutions. No value makes absolute value negative. Example 2, we're going to look at solving inequality, absolute value of inequality this time. So difference between equation and inequality, obviously the equal sign, instead of equal sign in equations, inequality will have less than or greater than equals to, or less than equals to. And the way that you're going to solve inequality, everything else is going to be same as equations. Only thing different is whenever you're multiplying or dividing by a negative number, you're going to flip the inequality signs. So let's try the example A. I see the absolute value of 2x plus 1. That's less than 7. So first thing I have to realize is one side is just absolute value, nothing else attached to it. Then I should be able to drop the absolute value and plus minus sign on the other side. So I will have 2x plus 1 with 7. And I will have 2x plus 1 with negative 7. The reason I didn't write my inequality is because depends on which number I have, inequalities will stay same or change the order. So this one right here, you have positive 7 you started. And first one I have positive 7. So nothing else is changed. Means that I'm going to keep my inequality, which is going to be 2x plus 1 last, right? This one right here, I started positive, but I end up using negative 7 because whenever you're taking off absolute value, one with the positive, one with the negative, right? So positive to become negative, you're multiplying negative 1. And I just mentioned whenever you're multiplying or dividing with negative number, you're going to flip your inequality signs. So this one, you're going to make it greater. So you flip the one with the negative sign, you flip the inequality. So instead of less than, you have a greater now. And all you need to do is solving it, right? Solving both inequalities. If you don't want it to work as 2 inequalities, then you can also make it as the complex inequality, which you're going to write 2x in the middle, and then we had less than 7, and this is greater than negative 7. So if you don't want to work two inequality, you can combine it as compound inequality and solve. And compound inequality, what you do is whatever you do in the middle, to isolate x itself, you do all three sides, right? So let's see. The first thing I need to do, I will do subtracting 1. It means I'm subtracting 1 on all three sides. I will end up getting negative 8 on the left side, and then 2x in the middle, and 6 on the right. Now we're going to do dividing by 2 to isolate x. And I'm dividing with positive numbers, so my sign will stay same. So my sign will stay same. In the middle will be now x. And negative 8 divided by 2 is negative 4. 6 divided by 2 is 3. So your solution is x, because you read from the variable always. So since variable is in the middle, you will say x is smaller than 3, greater than negative 4. And whenever you are solving inequality, we need to answer with graph and interval notations. I like to graph first. And always smaller number on the left, larger number on the right. And it say x is smaller than 3, which is on the left side of the 3. X is greater than negative 4 is right side of the 3, which is in the middle of those two numbers. The middle part. And you can use either parentheses or circle. Open circle when you have greater than or less than. And I like to use the parentheses. So if you don't have greater than equals to, if you only have greater, no equal sign, then use the parentheses. It means that you're not including that point. And you can also use the open circle if you want to. And interval notation is going to be just as the graph. So you have a parenthesis on each end, so you will have a parenthesis. And put these two number in the middle of the parentheses. So it will be negative 4 and 3. So your solution is going to be, for that problem, graph and interval notations. Let's try another one. So if we have absolute of 5 minus 2x is greater than equals to 5. So greater than equals to 5, we're going to use bracket or closed circle. Less than or greater than, we're using parenthesis and open circle, right? Whenever you have an equal sign, you use the bracket or closed circle. And what I notice is that I only have absolute value, nothing else attached. So I can take out absolute value and one with the positive 5. And we started with positive 5 will stay same. Inequality signs. But if we have one with the negative, we flip the signs, right? So if we flip the signs, 5 minus 2x should be now smaller because it said in a given problem 5 minus 2x is greater than equals to. So one with the negative should be 5 minus 2x should be less than equals to. So if I draw less than equals to, it looks same, right? It looks same as what was given, but it's opposite. Why? Because the middle value, 5 minus 2x, place was flipped, right? It was on the left side in the problem, and now it's on the right side. That's why the sign looks same, but you're reading from in the middle, so it will be less than equals to this time. And now you're going to solve for x. So first thing you're going to do, you're going to get rid of addition subtraction first. So you're going to subtract 5 to get rid of 5, positive 5. You get negative 10, negative 2x, and that's going to be 0. The second thing you wanted to do to isolate x, you're going to divide all three sides by negative 2. And remember, absolute value, any inequalities, when you're dividing with negative number, you change your inequality directions. So now this become opposite directions. And let's see, what do we have in the middle? It will be just x itself. Negative 10 divided by negative 2 is 5. 0 divided by negative 2, that's still 0. And when we're graphing this, don't forget smaller number on the left side, larger number on the right side, and we read from in the middle where a variable is, right? So it's a x is smaller than equals to 0, which is going to be on the left side of the 0, smaller, and x is greater than equals to 5. So that will be on the right side. And if I color that, it will be on this side and that side. And with equal sign, so we're going to use the bracket or a closed circle. So if you use a closed circle, it will look like that, right? And how are we going to write this in interval notation? Well, if you have a two set of solutions, we're going to use OR. So it will be one with the bracket, and when it goes to all the way to infinity, this time negative infinity, positive infinity, we're going to use the parenthesis because we don't know what last number that's including, right? And bracket 5, this is positive infinity, so it will be parentheses. And in the middle, because we wanted to count both of them as the solution, we're going to use the union sign, or. So your solution is going to be right there for that problem. Let's look at one more. We have absolute of x plus 3 plus 5. That's greater than equals to 12. First thing I notice is that I wanted to isolate absolute. It means I need to get rid of positive 5. So I will subtract 5 from each side. Then I will end up getting absolute of x plus 3 is greater than equals to, that will be 7. Once one side is just absolute itself, I can drop the absolute, and one with the positive 7, which is the same thing, will have the same inequality signs, but one with the negative, I will flip the inequality, which x plus 3 will be now smaller than equals to. Then let's do subtract 3 to isolate x in the middle. That gives you negative 10. That's x. That's positive 4. And when we're graphing it, smaller number on the left side, that's negative 10, is smaller than positive 4. Positive 4 on the right side. And if we read from the middle, it say x is greater than equals to 4, x is less than equals to 4. Negative 4, negative 10. So less than negative 10, less than equals to negative 10, greater than 4, equals to 4. So then this will be this 2 side again. And I do see equal sign, right? So I will use the bracket, not the parentheses. Then I will have negative 10 to negative infinities, or 4 to positive infinity for that problem. Example 3. We're still solving, and I wanted to show you 2 special types of inequality answer. So if we're looking at the first one, it's a absolute of x is greater than equals to negative 4. In this one, you realize that you have a negative number with absolute. Whenever you see only negative itself, you have to be careful because sometimes you don't really need to do much work for it. Remember one of the questions we went over saying that absolute of x equals to negative numbers. Let's say negative 3 maybe. And I told you this is going to be no solution because the absolute value cannot be equals to negative numbers, right? So x will have no solutions. For the same reason, when it say absolute of x is greater than equals to negative 4, you will say this times x will have many solutions. The reason is because, like I said, absolute values have to be positive, will never be negative. So no matter what x I use it, this statement will be always true. So for example, if I do absolute of 1, that is greater than negative 4. If I do absolute of 100, that is greater than negative 4. Even if I do absolute of negative 100, that is equals to 100, which is greater than equals to negative 4. That's the whole reason your solution will be many solutions. And the way that you're going to show interval notation with that will be negative infinity to positive infinities. And when you wanted to graph it, it's coloring all the number line, right? What about B? If we have absolute of x plus 6 minus 3 is less than negative 5. Even though I have negative right here, I wanted to do one more step before I decide. If I still have negative after I move negative 3, then I don't really need to work on it. I will see if it's many solutions or no solutions. But as it is right now, we don't know that because we still need to isolate absolute value before I decide that. So I will do adding 3 to isolate absolute value. Then I will get absolute of x plus 6. That is smaller than negative 2. Now, isolate absolute, and the other side is negative numbers. So now I can tell, I know that absolute cannot be smaller than negative numbers because absolute have to be positive. You will say x have no solutions. No matter what x I use, this side is going to be always larger than negative.
that will never satisfy smaller than negative 2.